Thank you very much, Christian. So in the movie industry these days, we all know technology is dramatically influencing how movies are shot. Still, a lot of films are shot on actual film, but more and more they're being shot on digital cameras, and it's pretty clear that's the way it's going to go. There's already digital projectors across the country at the Beverly and in Savoy. There's a lot of digital projection going on. And we've all probably heard that visual effects are being done very digitally. In fact, it's getting to the point where even the actors we're seeing in our films are being rendered digitally as well. And that's obviously a pretty key component of filmmaking. So I'm going to talk a little bit about digital actors today. And to talk about digital actors, we should first of all think about, well, what do we mean by, real actors? So this is, I think, traditionally what we think of real actors, who are, folks who go up and say the lines of a that are written in the script and interact with each other. Or often their performances are directed in some way. So those are clearly real actors that we go see. Now, this is sort of a theater situation, and that's not the principal form of entertainment that we have today. More likely today, we're going and we're seeing things in the movie theater. So the question is, are these real actors here? And that's actually debatable, because when you actually go to a movie, you're not really looking at real actors. It's actually a room full of people staring at a white wall for 2 hours. And the actors themselves didn't have to do anything that particular night, and they don't even have to be alive anymore. So there's a lot of question. Are we going to be bringing back actors from the dead so they can perform again? Well, you can rent Casablanca tonight, and you can see that already. But that's not what we really mean by the digital actors of today that are sort of changing things. And what are we more interested with those? So what do we need to have something that we can call a digital actor? And these are sort of the things that we're thinking of these days. We need some digital, like computer graphics representation of a human being that you can render from any viewpoint, so you can see them in 3D and anywhere they need to be relative to the camera. Very importantly, they need to be able to be lit by any illumination. Cinematography is very important in movies, and even if you're shooting home video, the way that your face and your body look in any particular scene is completely determined by the light that's around you, the bounce light from walls coming up from the floor, obviously the light sources in the room. It has every impact. So your digital representations need to reflect light the same way as real people. And then obviously the performances need to move, so somehow you have to get them to perform. They can't just be static. And you'd like it to look, if it's in a live action film, quite photorealistic, and sometimes you need it to resemble a specific person. So some of the work that I've been involved in at UC Berkeley and then continuing on at the USC Institute for Creative Technologies has looked mostly, or most particularly, at the idea of trying to see actors in any illumination, so capturing how people's faces respond to light, so their digital representations will actually respond to light the same way. We've built a number of devices that we call light stages that essentially a person can sit in, and it will record how that person's face reflects light. The first one was made out of materials that we just got over several trips to Home Depot to rotate a 250-watt spotlight on a spiral around. This was all pulled by ropes at the time. And in the course of a minute, we would get a data set from a video camera illuminated, showing the face lit from every direction that light could come from. So we trained a little handy cam at the time on one of our undergraduates' faces here. And if we look at all those images we get, we can kind of put them into a two-dimensional grid of lighting directions. And then if we have a lighting environment, this is light from a cathedral that we captured in a radiometrically accurate way, so we actually know how bright those windows are, how much bounce light's coming from the walls, and that bright yellow light from the altar there. Sample it into the same form, and you can essentially light his face with that light by modulating those images by the light in the environment and then adding them all together. And that actually produces an image of his face lit by that light. And you can see, like, the cathedral, the altar is giving a little bit of rim light around there. This is the stained glass windows reflecting in his hair. And that's all pretty easy to do. We're just adding images together. But that particular performance, we don't have viewpoint control yet. and we haven't been able to make it perform yet. So those are some other requirements. But it does look quite real because it is so based very closely in reality. So I was very fortunate to have the opportunity going to the Institute for Creative Technologies to get to work with a team of people to build some more light stages. And we built a somewhat more professional one out of a semicircular arm of strobe lights. This is actually a long exposure photograph of it rotating around, so it looks like it's a full sphere of light, but it's really just a crescent of strobes going off. And being in the Los Angeles area, we're pretty close to effects studios like Sony Pictures ImageWorks, for example, where the visual effects supervisor had read one of our research papers and asked if we could look into using this technique to help them make photoreal digital stunt doubles for the movie Spider-Man 2. So this is back in 2003. They had Alfred Molina, who plays Doc Ock, come over, and they brought over these high-resolution motion picture cameras, and we captured these data sets of how his face reflects light that could be projected onto 3D geometry of his face. They scanned that separately with a cyberware laser scanner. And they essentially had relightable texture maps of his face. So this is a computer rendering of Alfred Molina that is illuminated. I don't know if it's possible to turn these lights off here, but we might be able to see a little bit more. It's actually, that's cool. It's done with the data from the light stage, and the folks at Sony ImageWorks even got it to work where you can put computer-generated sunglasses and hair onto the character. And so it looks, you know, a pretty good bit like him. They also put a facial animation rig using relatively traditional techniques to animate the face, and this process actually got used in about 40 shots in the movie. So in this shot here, that's a totally digital guy there. He's also got digital clothing. And has been animated with the very talented animators at ImageWorks. And all of these stunt scenes were either just too much body motion, too crazy camera motion to really do with the real actor very safely. And the result was that they could actually get a lot of these effects shots done in a way that was a lot more practical than trying to shoot it for real. His death scene was deemed a little too dangerous to actually put the real actor submerged in water acting like he's dead, because you could get confused there. So this became sort of a standard part of their process, and they pushed it a little bit further for the movie Superman Returns, which has a number of shots of a digital Superman character based on actor Brandon Routh that we scanned. And they knew they were going to use it for all of the stunt sequences, but there were even some close-ups that were originally shot of the real actor on green screen that for whatever reason, they didn't have the light quite right on his face, so he didn't really look like it was there when they integrated him into the environment, or maybe the camera motion control was a little too slow or too fast from what they ultimately realized they'd like to have in the shot. And they realized that even without calling the actor up again, they could recreate the shot using their digital stunt double, who looks real enough that it'll pass off as it's the real guy. And then they have complete control over the lighting and complete control over where the camera is. And they also have a facial animation rig on the fellow here. They've kind of posed the digital actor's face, starting from the neutral expression to be a little bit of a smile. This is toward the end of the film, and things have worked out okay, so he's happy about that. And they did this for a number of shots in the film. So digital actors have actually been around for a while. But in both of these cases here, they're not doing a lot of acting close to camera. So they're sort of like digital stunt doubles. And whenever they really did need to say anything, they cut to the real person. There was a movie that came out around Christmas of 2008 that tried to push this much further, and it's regarded as sort of the first movie that really achieved the idea of a photoreal digital actor, which was The Curious Case of Benjamin Button. And our light stage technology played a bit of a role in it. Some of our lighting techniques played a bit of a role, but it was led by this amazing visual effects studio in Venice, California called Digital Domain. Used a number of different technologies and their own amazing technological artistry to pull this off. But I'll show you a little bit about what we did. The reason that they needed to do a digital actor is because in this movie, Brad Pitt plays a character that ages backwards. And for the first 52 minutes of the film, it was deemed that he doesn't look enough like himself that they can just use makeup effects. They really have to go with a fully three-dimensional version rendered of his face. So in this image, this is all computer graphics, pixels, and polygons here merged onto the top of someone else's body. They would get older small folks to play the body as he sort of grows up in reverse. And to do this, there was a lot of artistry in addition to technology, and they asked Rick Baker's makeup studios to create a maquette or a sculpture of Brad Pitt in silicone, the way he might look when he was older. And they brought it over to one of our light stages. This is light stage 5 at this point, which has a full sphere of LEDs. You can see this eerily realistic silicone head that came out of a box, and we put it up in there. And Digital Domain asked if we could shoot a data set of how this thing reflects light. So you can see it's got an amazing amount of detail. And we shot one of these data sets of it lit from every direction. And they weren't ultimately going to use these photos directly to create the digital character, but it was excellent reference for them for how an approved version of what he should look like when he's old reflects illumination in any kind of lighting environment. So this allowed Digital Domain to do this image-based relighting process on all of the lighting environments in the movie. And there's 325 shots toward the beginning of the film where the digital head has to appear, and every single one of those scenes, they shot what the lighting was like, this omnidirectional image of where all the lights and indirect light is. And then you can just directly multiply those images up to show what that head would look like in those lighting conditions. So when they're doing the full 3D version of it that's animatable, they can make sure it's going to drop in there correctly and match up to what you would expect reality to be. So these are some clips from the film here. And I'm going to plug in this thing here. Well, I don't think we're going to hear the audio because I don't see. Oh, here it is. So you'll see how this really came together. That's
now when I look back on it, it was miraculous.
And they replaced the head, and there's Brad Pitt actually performing the character on video, and they animate it to do what the video did. I'll say a little bit more about that. And this is probably about as hard as it gets to match computer graphics
there were
to
many changes.
reality.
Some you could see, some you couldn't.
There's the lighting environment
Hair
around it.
started growing in all sorts of places, along with other things.
I was born with some form of disease.
What kind of disease?
I was born old.
I'm sorry.
No need to be. There's nothing wrong with old age.
And this is the last shot in the film that's the digital head, and he's pretty close to his normal adult Brad Pitt age there. And then right after that, they would go to the makeup effects to make him look a little bit older at that point. So that was a very cool project to be a part of, because they really did get to the point where you'd see the film, and most people didn't even realize that there was all that much computer graphics in the movie. Now we've continued to try to do work in this area using our Light Stage 5 device. And one of the other companies that worked on Benjamin Button that analyzed the video of Brad Pitt's performance to help come up with the first pass of animation to drive that, and then Digital Domain did many more things to get the final performance as well. But a company called Imagemetrics in Santa Monica was interested in working with my lab to try to create a digital version of an actor, just with a combination of their animation technology and our facial scanning technology. And we'd recently improved our face scanning technology to the point where we could get relatively high levels of detail of even the geometry of the face, in addition to the reflectance. So this is an actress named Emily O'Brien, who plays Yana Hawks on The Young and the Restless, and she came in for an afternoon to get scanned. And we used a new face scanning process that actually uses quite a bit fewer images and polarization to separate reflectance. And the idea, this is actually a digital version of her that was created. The idea was to shoot real video of Emily and then see if we can replace her face digitally, and maybe you won't tell that it's a digital person. So after they shot some real video of her there in high def, brought her over to the light stage, we scanned her. Nowadays, we're using polarizers to separate diffuse and specular reflections. So there's the diffuse component. This is the shine off of the skin. And that helps us analyze the shape of the face at much higher levels of detail. We can get like skin texture and the little folds in the lips and all the things that happen when she creates different facial expressions. And since this only takes 3 seconds to scan now, we could shoot her in many different facial expressions, which helps her digital character move the same way that Emily's face actually moves. If you look at all of these different images of what shape her face is when she does expressions, there's an amazing amount of different scales of change that happen in a face as it goes to these different expressions. So we were able to capture all of that. In addition to the geometry, of course, we still get the way that the skin appears, so we can project those photos back on to get the coloration. We can even analyze the photographs to figure out the translucency of the skin so that that can be used for some subsurface shading algorithms. We gave all that data to Imagemetrics, which created what's called a rigged digital character. This face rig here are little strings that you can pull on, and it makes her face make different shapes. This is just a low-resolution preview. And all of those shapes and the detail that's eventually added on top of them come from the scans that we took of Emily. So then they analyze video using their facial animation process. They look at frames, they pose the face to match certain frames, and then the computer figures out all the other interpolations from kind of making analogies between these. And then they can drive the digital face. This is still low resolution, it hasn't had the detail on it, but they can drive the digital face with her performance. And then if we move that on top of her face, put on the skin shading algorithms, and add all of the detail, you get this result.
Imagemetrics is a markerless, performance-driven animation company. We specialize in high-quality facial animation for video games and films. Imagemetrics is a markerless, performance-driven animation company. We specialize in high-quality facial animation for video games and films.
Just to pull that apart, that's the diffuse component of the skin reflectance. Her specular shine looks a little funny, but that's it on its own. And there's the underlying wireframe. And if you pull it all away, you can look at real Emily there. And we're not identical to real Emily, but a lot of folks, the first time they see the digital Emily, they're willing to accept it as a real human face and hear what it's saying and read emotions from it as well. So that was another cool project to be involved in. And the most recent project that we had some contribution to some of the facial work in was the movie Avatar that came out pretty recently. And it's well known that there are a lot of digital characters in Avatar, and most of the ones that we know about are not human. So you might wonder, well, how would we scan somebody, or why would we scan somebody to create, a blue alien? But it was actually very important to the filmmakers that the digital versions of these aliens would actually, as closely as possible, in key ways, be based on the real people who were the actors behind the performances. And in particular, this here is the lead female, Neytiri, and we actually scanned Zoe Saldana, who was the actor who provided the performance and the voice of Neytiri, and got all of that detailed skin shape and such. And that was part of something that was put into the mix for this amazing visual effects company, Weta Digital, that did the Lord of the Rings films. They also did most of the effects for Avatar, to use in creating the digital version of this character. And so pretty much from the cheekbones down, this is almost literally Zoe Saldana, and the rest of it has sort of larger eyes and a broader nose and things like that. But it was realized that if you're going to have a human driving a different character that's not quite human, it's much better, for sake of that performance, to be able to have that character have some of the same facial shapes, so that every way that this person has learned to use their face and the meaning that people read off of their face that they've gotten feedback on is relevant to how they might drive this character once that's what they're going to look like on screen. So there's Zoe there in the light stage getting scanned. We also scanned Sam Worthington, and there he is patiently waiting while we got the full equipment to work again, and got some data of him. He shows up both in human form and in avatar form, and kind of Na'vi form. And according to the story, actually, the Na'vi form of him is based somewhat on his DNA. So there's even a nice story explanation as to why the blue alien version of him should look something like the actual actor does. And this is some of the data that we captured. In fact, actually, his human form is also completely digitally rendered in some of the scenes as well. When you're putting a human character into a completely computer-generated environment, it's actually easier if they are a digital element themselves, that you have control over the viewpoint and the lighting, rather than trying to just take a green screen element and stick it in there, where you have to try to get all the viewpoint and lighting right or close enough at the beginning. So they had a very nice digital version of him too, as they also did for this fellow here, Stephen Lang, who plays the bad guy. And in a lot of the stunt sequences afterwards, they use a digital copy of his face that they also animated pretty nicely to be used in those stunt sequences. So at this point, we can ask ourselves, so do we have photoreal digital actors? And actually the answer to that, it's not quite posed right. The answer to that question, I think, is actually no. Because the actors here were actually not digital. The actors were real human beings. And the extent to which those digital characters really did the important things that actors need to do in a movie is still based almost entirely on the fact that they had excellent performances directed by excellent directors in a way that served the story. And in all of these processes, the digital version of them was doing as closely as possible and as faithfully as possible something that the original performer was actually doing. In Avatar, they had these little facial cameras that watched every motion of people's faces as they acted out the scenes in motion capture suits to drive the bodies. And with Brad Pitt, they used that video to drive the digital version of the character. So I don't think, even though we can now do photoreal digital faces, we don't have photoreal digital actors. We still certainly need actors. We have more like photoreal digital puppets or photoreal digital makeup for performances. And the whole process of filmmaking is still very much what it always was. We just have some new creative tools to take it into new directions that were much more difficult to do in the past. Thanks.